Paula Holmes. I'm a junior computer science major at Mount Holyoke.
And I'm Emma. I'm also a junior at Mount Holyoke studying computer science.
Yeah, so this semester we made a hydroelectric generator, and the idea in the start of this whole process was that we really wanted to truly understand how electricity is created. What does it look like? How do we actually make it? So we did a lot of research at the start.
Mm-hmm. And I think because we're both programming students, we wanted to work hands-on as much as possible. So we decided one of the best ways to do that was to work with recyclable materials and
low cost.
Yes, which is actually very difficult, as we discovered with creating generators.
And to keep with the environmental theme of the class, we wanted to make a hydroelectric generator.
Yeah, and that could possibly help other people's projects that we were seeing in the class, because a lot of the presentations you'll see are actually doing water sensing. So we thought, you know, what would be better than being able to power their Arduinos for their projects so they could have long-term studies. Okay.
So this is a photo of our end result. We found a DIY instruction manual online, and we went through it, and we saw some errors, and we edited it, and then we did a trial, and it fails, and then we remade it. And this is what we got to. So what you see here is a Frisbee. And glued to the Frisbee is a bunch of magnets alternating from north-south side. Underneath are coils of magnetically charged wires, enameled wires. And then underneath that is our spoon turbine. And the magnet plate and the turbine are connected, so they spin together.
So one of the things I actually found really cool when we were researching this is that, as it turns out, people use spoons a lot. You see that in a lot of designs, which I don't think I would have ever thought to use, but it's very functional. So that's one of the things we decided to keep with. However, we had to work out certain processes to be easier and more functional. So we were able to use, oh, I don't think we have a picture. No. We were able to use handheld tools and things to make it easier to make. And to make the spools of wire in particular, we used a drill as opposed to doing it by hand, which was very uneven. And then we can talk about some of our struggles and successes.
So a great accomplishment is that we did generate electricity.
Yes. So the goal was met. However, we did not generate all that much electricity. And one of the things about generating electricity is that a lot of devices don't actually function well with an uneven flow. This would be charging a battery for the device, not directly. But even so, the uneven flow isn't very good for a device.
An example of how much electricity we made and did not get to is that one single LED. You guys, everyone knows what that is? One. It takes about 1 watt for it to light up.
Yes.
And we were not able to light up LED.
I think technically we made 1 watt, but we still weren't able to light up an LED. So. But one of the other things that was really great was that we got to research generators and how other people are making generators from scratch, which was really, really cool. As it turned out, though, not all of those designs were something we could make, especially because we had limited access to power tools, and not all those designs were very good. So we really had to dig through different designs, but we learned a lot more about what works and what doesn't work.
Another success in our experience is that we learned how to use SketchUp. When we were trying to remake a second model, we were considering, oh, well, what if our turbine was more straight and not crooked with the spoons, and we would have an even flow of or even rotation. But unfortunately, our design was too big to print in the 3D printer that was accessible for us, so we were not able to actually print our SketchUp.
Yeah, but using SketchUp was really cool because we were hoping that it would be something a lot of people would use, and it's free to download and everything. But it is definitely a problem that a lot of people probably couldn't print it like we couldn't. And then finally, I think we really worked through a lot of design problems we had, even if we didn't completely fix them. And in working through those design problems, we actually broke one of our magnets. So we had to work through that design problem as well, which was interesting.
But as it stands, we think that it's actually very challenging to generate electricity out of common household items, possibly. So if anybody has any ideas, we'd like to know.
Yeah.
Thank you.
Thank you.
So any questions for these guys while I bring up the virtual Liz, who's their next presenter?
Sure. I'm curious what kind of voltage and current you were generating.
So I think the maximum we generated was like 1 or maybe 2 watts. So I don't think, we didn't test it that extensively.
For voltage, okay.
Yeah.
Because, you'll need a certain voltage for the LEDs.
Mm-hmm.
You may not have gotten okay. The second question I had was, how big was your second design that made it too big to print on the 3D printer?
So we just had a really small 3D printer. We wanted to print it about like less than a foot, really. So
And the limit of the printer was less than that?
yes.
Yes.
Like,
Yeah, 4 inches.
Okay, so you were wanted about like 10 or 12 inches, and the limit for the printer was 4 inches.
Yeah. So we had to kind of go back. And I had wanted to design it so we would just design it in pieces and then be able to put it together. But we never got to that part, so.
So one of the issues related to printers is we have a group in UMass Engineering called M5, which is a makerspace there, and they have at least 1 and possibly 2 3D printers that I saw that were bigger, possibly. So we didn't know that at the time when they were doing this. They were working with just a terrific professor at UMass named Alex Schreier, who was letting us use his printer, but it was a little smaller.
Yeah.
And there is talk about possibly getting more 3D printers. Jay, is it okay? Okay, I wasn't sure in terms of where we were at on this, but the library at Du Bois Library is getting 3D printers for the students. So there's going to be more opportunity. And then finally, the high school at Amherst High now has some 3D printers too. So there's seems to be more capacity for these kinds of projects for students. So. One more?
What were you using to drive the propeller? Did you actually put it in water in a stream or something?
So it actually works better with like 1 stream of water. So we were testing it inside because we were testing it mostly in the cold. So we put it under a faucet and things like that.
Yeah, at Mount Holyoke we have these cool faucets where it just fills your water bottle like directly. So we just put it under there.
Yeah, we were in an academic building holding a generator which was spinning.
Water, even better.
Yes. So.
We're going to hear from Brett in a few minutes about his project, but one of the things that he's doing is actually putting a device in the field for a long period of time. So we had some conversations about their device sitting in a stream and then somehow powering a device like Brett's device. So it was some interesting conversations about that. So thank you guys very
thank you.
much.